In this video, I am going to introduce some topics or concepts related with force. Force is one of the most important property that we study in physics. So the first question is, what is force? So we can say that in simple language, we can say pull or push of a body is called force. Or in detail, we can say force is that physical cause that changes or tends to change dimension of a body or the state of rest or motion of a body. Standard 11, we study Newton's law, and in this chapter we study inertia. And you can say that inertia is the condition of a body. It is a state of a body in which a body remains in a state of rest or motion unless an external force is applied. So if a body is in a rest, the body will remain in a rest. Or if the body is in a motion, the body will remain in motion unless an external force is applied. That's why it is that physical properties, you can say that physical cause that changes dimension or state of rest or motion of a body. Different types of force we study in physics. First, force of gravity. Second, normal force. Third, force produced due to tension. We can say tension is a type of another force. Force of contact, gravitational force, electrostatic force, magnetic force. For example, if a body is kept on a surface and m is the mass of a body, then we can see that here gravity or force of gravity, that is m into g, will act in a downward direction. And in respect of that, body will press this surface, so another force will produce, that is normal force. Very, very important. So we can say that force of gravity is equal to force of normal. First point. When a body is kept on a rough surface, this is the smooth surface. When a body is kept on a rough surface, then apart from force of gravity and normal force, and another force will produce, that force is called friction. And friction always opposes motion of a body. If we apply a force on a body, that means external force. Force applied by a person, a body, is called external force. So the first force that I have explained is the force of gravity. Second is the normal force. Third is the force of friction. Fourth is the applied force, or you can say that external force. Applied force or external force. Fifth is the when you are connecting a body with a thread. Here. Suppose this is M1, this is M2. Then here another type of force will produce, that is tension. So tension is another force that we apply when we are going to use strain. When you are connecting two or more than two body, then here A and B and C, between A and B, another force will produce. Here we can write like this. Here. This force is called force of contact. So this is force of contact. After that, when we are considering two bodies having different masses and they are taken at a fixed distance, then here another type of force will produce. That force is called force of gravitation. Very, very important. So you can say that force of gravitation is a type of force that we will use when two bodies having their masses are taken at a fixed distance. Force between moon and sun, force between earth and other planets, force between earth and sun, all are example of force of gravitation. After that, force of electrostatic, or you can say electrical force. This type of force will produce when in place of mass we take two bodies having charges and they are taken at a fixed distance. Then force of magnetism or magnetic force. You can say magnetic force, that is when force develops between two magnets, that force is called force of magnetic force or force of magnetism. So these all are the different type of forces. Some are attractive in nature, some are repulsive in nature, some are both attractive or repulsive, some will oppose the motion, some will support the motion. These all are different types of force, and the purpose of the force is to change the dimension or state of rest or motion of a body. Whether you are going to take normal force or friction force or force of gravity or force due to tension, all will have a common unit, that is Newton, and all will have a common dimension, that is ml2t minus 2. Doesn't matter what other factors we are taking, but their unit and dimension always remain same. So here I am going to introduce electrostatic standard 12 class. In the previous video I have given what is electrostats, what are the important points that we have to study basically for the board exam, and I have also given electric dipole, concept of electric dipole. In this video, I will give information of electrical force, what is the force, what is the magnitude of the force, how will force changes when the medium between the two charge body will change. So here I am going to introduce electrostatic force. Electrostatic force, the concept of electrostatic force was given by a scientist. It is also called Coulomb's law. And this is a quantitative statement. Very, very important point. That means with the help of Coulomb's law, we will find magnitude of the force between two charges, their measurement. Second, if the linear size of a body is smaller than their distance, then it is called point charge. Very point charge. Here very important concept that Coulomb's law is applicable for the point charge of the body because the size of the body is smaller than the distance between two or more than two charged particles. So Coulomb explained that if we take two charged body, if we take two charged bodies, suppose Q1 and Q2, this is the point charge, and R is the distance between the two charged body, then a force will develop. That force is directly proportional to product of magnitude of the two charges, and the force is inversely proportional to square of the distance between the two charges. So we can say that this is equal to Q1 Q2 by R square. Here to remove proportionality, a constant K is used. This is Q1 Q2 by R square. Here K is equal to 1 by 4 pi epsilon naught and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. So the first question that can be asked in the board exam is the very important points. From here I will explain where you have to keep attention so that questions may be asked in the board exam, that may be objective or subjective questions. First is what is epsilon naught? Very important. Second, what is its unit and dimension? So here epsilon naught is called absolute permittivity of free space. It is free space, or you can say that vacuum. Its unit you can find here. K is equal to 1 by 4 pi epsilon naught. So here you can write 1 by 4 pi epsilon naught Q1 Q2 by R square. Directly from here also you can find, but I will use this formula to find this. 4 pi has no importance. So epsilon naught is equal to Coulomb square Newton meter square. You can apply here also. 1 by 4 pi epsilon naught Newton meter square by Coulomb square K. So you can say that it is Coulomb square, this value, cross multiplication will you get, Coulomb square divided by Newton meter square. Dimension of Coulomb is AT whole square. Newton is MLT minus 2. M is the meter square, L square. So it will be A square, T square, M minus 1, L minus 3, T 2. So it will be M minus 1, L minus 3, here T to power 4, A to power 2. This is the dimension of absolute permittivity in the free space, and its value is equal to 8.85 Coulomb square in Newton meter square. So when we are going to solve numericals based on Coulomb's law, we have to use this formula and we have to learn the value of K, that is 9 into 10 to the power 9 Newton meter square by Coulomb square. Sometimes we have to know this part also, because if it's a question, there is information related with absolute law, that is absolute permittivity, then you have to know its value. And in the board exam, there are some terms that you need to memorize in the exam so that your speed reading is fast. So this is the information. Now here, the point is that if we want to represent this force in a vectorial form, in the vector form, then how will we represent? So that is important. How we are going to represent this in the form of vector? Because force is a vector quantity, it has magnitude as well as direction. So here, if we want to say, suppose this is the origin, here is the Q1 charge, this is at origin R1, and this is the Q2 charge. Here is the force. Here is the force, first on the second body, second on the first body. This is R2. So we can write like this, F21. This is the force experienced on the second board charge due to the first charge is equal to 1 by 4 pi epsilon naught Q1 Q2 by R21 square R21. This indicates unit vector, that is its direction. Here one thing I want to say, that suppose these two charges are same nature, either both are positive or both are negative, there will be force of repulsion between the two charges. So this value will be equal to this value. That is, you can say that direction of force is equal to direction of the distance on the between second and first information. If this one is positive, this one is negative, then there will be force of attraction. So here we can say F21 is equal to minus the direction of force will be opposite to the direction of distance. So this is the representation of force in the vectorial form. You can write like this also in the form of vector, and questions may be asked, express the Coulomb's force in the form of vectors. When the attractive force, then direction; when the repulsive force, then direction. It's here Q is equal to charge and its unit is Coulomb. So if we write this, suppose F we take 1, suppose if we take Q1 is equal to Q2 is equal to 1 Coulomb and our distance is 1 meter, then force will be 1 Newton. So how will we define 1 Coulomb? You can say 1 Coulomb is the charge, very very important. 1 Coulomb is the charge when it is kept at a distance of 1 meter of another charge of the same magnitude, then it will experience a force of 1 Newton. You can say 1 Coulomb is the charge, and when it is kept at a distance of 1 meter from another charge, of same magnitude, then it will experience a force of 1 Newton. In the board exam, questions may be asked what is 1 ampere, what is 1 coulomb, what is 1 Tesla. So questions may be asked from the unit part. That is very, very important. How will you going to define the unit? The dimension part, that is very, very important. One questions, it is every year comes from the dimension part. So this is very, very important point. So how will you define 1 coulomb? Next point is that here we have calculated force between the two charges when the medium there is a vacuum, there is a free space. What will happen if you will take medium between the two charged particles? So here force in the medium can be anything in form of glass, in form of water. It will be 1 by 4 pi epsilon Q1 Q2 by R square. Here epsilon is called absolute permittivity in medium. It is in medium, and this by this is equal to, that is permittivity in medium to permittivity in air, is equal to a constant. Very, very important point. This constant is known as dielectric constant. So from here also you will get one question. You may get one question. What is dielectric constant? You can say dielectric constant is the ratio of permittivity of the medium to the absolute permittivity in free space. It has no unit and no dimension. That is very, very important. So its value epsilon is equal to epsilon naught into K. Here when you put the value F in medium, this will be 1 by 4 pi epsilon into K here Q1 Q2 by R square. So we can write force in medium is equal to 1 by K into 1 by 4 pi epsilon Q1 Q2 by R square. This is force in air. So we can write force in medium is equal to force in air or vacuum divided K. Very, very important information. This is very, very important information, that if a medium is kept between the two charged body, force will decrease. Force will decrease by its 1 by K value, that is its dielectric value. So now I will solve some question based on this topic, that is how will you find electrical force between two charged body and when medium is there or when there is no medium. So I am taking some question from your textbook, that is from NCERT, to explain this. So the question is, what is the force between two small charged spheres have charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart? This is exercise first question. That is Q1 is given 2 into 10 to the power minus 7 coulomb. Q2 is given 3 into 10 to power minus 7 Coulomb, and distance is given 30 centimeter apart in air. So directly you can put the formula: force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is 9 into 10 to power 9. Here one thing again I want to repeat in my previous video, how to solve numericals, what are the important points we have to remember while solving the numericals. I have already given, but still I want to memorize you. Repeat this. Here we have to convert SI, we have to use SI unit. This is given in centimeters, so 30 into 10 to power minus 2 meter, or you can write 0.3 meter. Anyone you can write. So it will be 2 into 10 to power minus 7 Coulomb, 3 into 10 to power minus 7 Coulomb divided by R squares, so 0.3 whole square. So this will be 9 into 2 into 3. You take power together, 10 to power 9, 10 to power minus 14. This will be 0.3 into 0.3, 30 centimeter, 30 by 100. This is 0.3. So this 10, this 10, 3, 3, 9, 3, 3, 9. So it will be 18 into 10, 10 to power minus 4. You can write 1.8, you can decrease this, you can increase this, minus, you have decreased this value. This is Newton. This is the force produced between two charged body when they are taken in a air or free space. This way we can solve numericals questions. Here in place of 1 by 4 pi epsilon, you can write K also. K into Q1 Q2 by R square, and you remember the value of K, that is 9 into 10 to power 9. So in this way you can solve the question. The second question is given: the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge in air is this. What is the distance between the two spheres? In the second question, magnitude of the force is given, charges, magnitude of the charges are also given, and you have to find distance. So in the second question, suppose the second question is given that Q1 force is given 0.2 Newton, Q1 is given 0.4 microcoulomb, Q2 is given negative 0.8 microcoulomb. We have to find distance. In this question, one thing you have to remember, micron, 1 micron means 10 to power minus 6. There are some points you have to remember when you are going to solve the question. What is the value of micron, nano, pico, fermi? These are the important information you have to remember while solving the numerical question. So it will be 0.4 into 10 to power minus 6 Coulomb. This will be negative 0.8 into 10 to power minus 6 Coulomb. Second thing you have to keep it in mind that negative sign has, this negative is not need to apply in the numerical questions. The importance of negative is only to show that whether the force of attraction or repulsion, because questions may be asked what is the nature of the force. For example, in the first question both the charges are positive charge, so we can say this force will be repulsive in nature. But here one force is positive, one force is negative, so we will say that here is force of attraction between the charges. So we can find F is equal to K Q1 Q2 by R square. You have to find R square, so K Q1 Q2 by F. Put the value of that. Q1 is 0.4 into 10 to power minus 6, Q2 is 0.8 into 10 to power minus 6. divided by force is 0.2. Second thing I want to say, whenever we are going to solve the numericals, we don't disturb power. Because see, there is a root. We have to put the value r, then we have to apply this under the root. So this will be under, we have to take it under the root. First we will solve this, then we will find this value, this will be cancelled. So 9 into 2 into 0.8 into 10 to power 9, 10 to power minus 12. You can remove this value. 10, that is 9 into 2 into 8 into 10 to power 9, 10 to power minus 30. R is square, so R is equal to root 9 into 2 into 8 into here 10 to power minus 4. See, this will be 16, 10 to power minus 4. So under root of 9, 3, under root of 16, 4, this minus 2. So 12 into 10 to power minus 2 meter, or you can say 12 centimeter. At the distance of 12 centimeter when we keep, this will be the force of attraction or repulsion. This way we can solve. Here also I didn't multiply because the question is simple, and whenever we are going to solve it, whether in the competitive exam also, don't multiply the product. It will consume extra time. Better that you wait just to observe that whether this part can be removed from the under root or not. It can be solved without touching the pen or pencil. Just you keep this point in your mind that multiplication and division. Suddenly you see the number and you started to multiply, start divide. Don't do like this. First you read and see what are the values given and whether it will be handled by you without multiplying or dividing. This is the important point. Its part is, what is the force on the second is prior to the first. So force applied by a first body and force applied by the second body, both are equal and opposite. So you can say this will be the same force applied by the second body on the first. Next question is given. Four-point charges. This is the group of force. Suppose there are two charges are there, you have to find, you simply apply force. F is equal to 1 by 4 pi epsilon q and q2 by r square. But you have group of force. Then here we have to apply principle of superposition. Here we have to use the concept of vector. We have to find individual forces and then we have to find resultant of the force using the concept of the vector. So in this question it is given that, this question I will discuss. The question is given that four charges QA, QB, QC and QD are located at the corner of a square of side 10 centimeter. So you have here the diagram is given in the pattern of a square and suppose charges Q1, Q2, Q3 and Q4 are given and the distance is 10 centimeter. QA, it is given A, B, C, D. A, B, C, D. So put the value A, B, C, D. Here QA is equal to given, its value is given 2 into 2 microcoulomb. It is 2 microcoulomb. QB is given, it is minus 5 microcoulomb. Minus 5 microcoulomb. QC is given 2 microcoulomb and QD is given, it is minus 5 microcoulomb. Minus 5 microcoulomb. And you need to find force at the center of the square, here 1 microcoulomb. Here you have to find the force due to all these charges. So in this case, first you need to find this the entire distance. Suppose this is 10 centimeter. So this will be 10 root 2. Suppose this is the 10 centimeter.